Okay guys, so yesterday we started to talk about our vertical angle relationship. We said when two lines intersect at a point, that the opposite angles, right, I can call them here A and A or B and B, are going to be equal to each other. And we said that the relationship exists because they are what's called the vertical angles. And we showed a little kind of simple proof of it yesterday. And today we're going to kind of continue along with the same relationship, and we're just going to talk about algebraic expressions instead of just simple variable expressions. So just as a little review, maybe we'll hit number 4. So I'm going to say angle S is 75 degrees because it is vertical to angle 75 degrees. Angle T is 35 degrees because it's vertical to the given 35-degree angle. And then I'm going to say Q I know is equal to R, and how would I find it? Well, I have to approach one of my straight angles, which I'll consider my blue segment a straight angle. So Q plus S plus T needs to be 180. So 75 plus 35 is 110. So that's 110 of my 180 degrees. So I take the difference. And that tells me that Q should be 70 degrees. And that R should also be 70 degrees. And we said there's lots of ways we can check. We can add any 3 consecutive angles and make sure they sum to 180, or really we could add all of the angles and we would make sure that they sum to 360. So all we have to do when we're dealing with these sort of applications is we have to determine whether the angles are equal or whether they're supplementary. And there's only 2 cases, right? So in other words, if I have angles here and here, right, I would say those angles are supplementary, which means that A plus B is equal to 180. Whereas if I had angles here and here, I would say they're vertical and A is equal to B. That's it. I'm only going to have 2 cases. So what do I notice here? I notice that these are vertical angles, right? They're the angles that are opposite each other, therefore they're equal. So I'm going to say the angle represented by the expression 5x minus 18 is equal to the angle represented by the expression 3x plus 6. So I've got 2x minus 18 equals 6, which means that 2x is equal to 24, which means x is 12, right? But what is it asking us to do? Find the missing angles. We haven't done that yet, right? We did the bridge step necessary to find that, so I need to find out the measure of this angle. So I need to know what 5x minus 18 is. So I substitute, I get 60 minus 18 is 42. So I think that this is 42 degrees. I need to do the same with 3x plus 6. All right. Now, as far as the check, I don't have to do a formal check because I know that if the value of x that I came up with gives me equal angles, that my answer is correct, right? That 42 is equal to 42 with only the value of x is 12. Let's say we had done this wrong and we got x is 10, just to give you a counterexample. Well, if x is 10, then 5x minus 18 is going to give me 32, whereas 3x minus 6 is going to give me 36. That means x is 10 is wrong. This is the only value of x that will give us equal values for both of these angles, which we know to be equal. All right. Let's do the same thing here. What's the relationship between these 2 angles? Now, every time I do this lesson, someone, we do the first one where they're equal, and someone tells me, okay, 7y plus 8 equals 137. And I reluctantly will set it up, and then someone will raise their hand and will say, well, that's kind of ridiculous because one of these angles is an acute angle, and one of them's obtuse. How can an acute angle be equal to an obtuse angle? It makes no sense. And of course, it does make no sense because they're not equal, right? They share a straight angle. They're what we call a linear pair. They're supplementary. So I don't need this. I need this as my straight angle. And then this is my ray that's cutting that angle into 2 parts, right? Obviously not 2 equal parts. One's acute, one's obtuse. So I know that this is going to be that other case I talked about before where the angles are supplementary. So the 137-degree angle plus the angle represented by 7y plus 8 is equal to 180. Now at this point, someone usually says, well, can't we do 180 minus 137, and that's the acute angle? And I can say, sure, we can do that, but they're still going to want us to find the value of the variable and the measure of the angle. So we're going to have to do both regardless. So I get 145 plus 7y equals 180, right? Which means that 7y is equal to 35, which means y is 5. So now we want to make sure we did that correct. So we're going to say, well, what's 7y plus 8 with y being 5? it's 43 degrees. And we're going to say, all right, I'm still not exactly convinced I got this correct. What can I do to make sure it's correct? And we're going to say, well, I need to know that the sum of those two angles is 180 degrees with the value we came up with for x. So I would add them, and that's my proof that we did this correct. So for this problem, we'd actually, the directions would have been to find y and find the missing angle. So we can do them in either order, but it's usually easier to start with the equation itself and then work our way back to find the angle. And this one we don't have a choice, right? Again, whereas with the last one we said, well, I can do 180 minus 137 and find the angle is 43 and then make this equation 7y plus 8 is 43 to find y. I can't do that here. So what we have to do is we say, what's the relationship of these two angles? Are they equal or are they supplementary? And someone's going to say, well, they can't be equal because 5y plus 17 is clearly an obtuse angle, and this is clearly an acute angle. And the other way we know that they can't be equal is that this is 17 greater than 5y, and this is 5 less than 3y. So that's really not going to work out either, right? We're going to get a negative value, which is not possible. So we're going to say, all right, I know that the sum of these two, since they're what's called a linear pair, right, they share a straight angle, is 180. So I know that 5y plus 17 plus 3y minus 5 is 180. So when I combine the like terms, I get 8y plus 12, which gives me 8y equals 168, which gives me y is 21. So now what do we still have to do? We have to go back and substitute. So what's 5y plus 17? It's 5 times 21 plus 17, which is 122 degrees. And what's 3y minus 5? It's 3 times 21 minus 5, which is 63 minus 5, which is 58 degrees. All right. Is this right? Well, I have no idea if that's right. Right? Why I could have got 10. I could have got, if I would have done it the other way, I think I would have got negative 12 for my answer. How do I know it's correct? Well, we expect these two angles to be supplementary. So we would expect if I added them together to get 180, and we do. And again, the only value of y that will give us angles that sum to 180 when substituted is 21, which means our value of y is correct, and it means the value of our angles is correct. Okay, so there's not much really more to it at this point, right? We did yesterday just finding the generic angles on their own. Now we're going to we looked at finding angles given algebraic expressions where we have to solve actual equations as opposed to just doing addition and subtraction. So you can pause it now. You can work on these. So for the first one, obviously these are vertical angles, so they're equal. So I'm going to add negative x on both sides. I'll also add negative 8 on both sides. That gives me 4x is equal to 36, which gives x is 9. And again, we need to find the angles as well. So if I sub in 9 here, 5 times 9 is 45 plus 8 is 53 degrees. And x is 9 plus 44 is 53 degrees. So no further check is required since the angles we ended up with are equal. For this second one, we would expect that since this is a straight line, this is a linear pair, they would have to be supplementary, right? We know they can't be equal since one is clearly acute, one is clearly obtuse. So that gives me 4x plus 76 is equal to 180. So that gives me 4x is equal to 104. So when I divide both sides by 4, which I don't have space to show, x is 26. And when I go and I sub it in here, 4 times 26 is 104, minus 10 is 94. And we're going to say, all right, that's great that we have this number here, but how do I know it's correct? Because my 86 plus my 94, when added together, it gives me the 180 degrees that I expected. All right, guys, so again, this would have been our classwork. Since we don't formally have classwork, right, other than the now try, we'll call this our homework. So the directions are going to be to solve for x and find the angles. Okay, so for number 1, you can't just say, well, the angle is 40. Well, we know the angle is 40, right? Or hopefully we know the angle is 40. Solve for x, substitute, and prove it. Same thing for 2, right? I know that that angle is going to be 105. So, write the equation, solve for x, substitute, and prove it. And for 3 and 4, you don't have a choice, right? You're going to have to write an equation to solve for x, substitute it, and find the variables. So again, guys, for your homework, you're going to draw the figures. And then to the side or underneath, you're going to write the equations. It's Should take you about 8 or 10 minutes. As always, guys, any questions, concerns, shoot me a message.